all the participants, we already shared the schedule. Almost we will proceed with the schedule. Just today just little bit delay, but otherwise everything go as per the schedules. So morning all we will have the lectures and afternoon we will have the tutorials. So to start with, so I'm going to start with my first presentation. Then I will hand over to our Professor Sridhar to continue further. So for any of this, when you are dealing with these hydrological extremes, most of the times when we want to model or analysis, whatever we want to do, first we need to have a reliable data source. With that reliable data source only, whatever we can plan, either analysis or modeling, we can perform with a with accuracy, and then the reliable results we can get. So just I will show you. I will just as a brief, like what are the available sources where you can rely upon, and then where you can work, and working with data, what type of things you need to follow so that we can have really say that as my analysis is so much reliable, and then we can rely, and accordingly you can proceed with the results. So the main thing just I will show here, what are the, you can say, available data sources, important data sources, and we can see the some node points. Like now everything is available on like a web system, right? Everything is available on web. Live, you can say webcast, actually live telecast, all these things. That's where they are asking IIT Hyderabad things. We are giving that one. I think what I want to say here, we can see that these lectures, once they will keep in the open, you can see public, you can also see once again these lectures. Later also you can just check those things, or you can go through those lectures. Here just I am saying, like we will see the what are the prominent data sources, and then we will have the what are the data selection. We are saying what are the different issues which will come. So we will also check with the important points in the data selection, or you can say collection. So those things we will check one by one. So what are the important data sets for hydrological extreme studies? What are the important things you see here one by one? Actually, first of all, any hydrological extreme study you take, so the main important data is the we have the climate or meteorological data. That is observed data that we can see. That is a first important data. Then we can look at the, you can say the most of the times your extremes we are predicting, right? You are predicting, or you want to, you can say project, or you want to identify, or later you want to know what is going to be the scenario. So for that we need to have the climate model data, either the regional climate model, or we can have the, you can say global climate data. So for historic and future scenarios, so more about scenarios, Professor Sridhar will explain what are those things and all things. Just I am saying that this is the one of the important data. Any extreme study people want to do, they have to go with these data sets. So then we have the most of times, especially we are working with floods. That is about things we need to have the digital elevation model. So nowadays we have the high resolution digital elevation model available in the websites. We will show some of those things today. Afternoon we will also try how to download from some of those things, and we can check how they are, what are the different sources. And land use land cover, especially either it is like a extremes, either it is a floods or we go for a droughts. So this land use land cover is one of the important thing. So we need to have the reliable land use land cover information for most of these models as an initial input. And of course soil data. So most of the drought studies is one of the very important data for the drought studies. So most of the times these all models, before you are going for either analysis you are doing, or you want to do some forecast. So we need to have some, first of all, like we need to have some calibration and validation. How we can perform that one? So for all those things we need to have this stream flows, groundwater flows, soil moisture, evapotranspiration. Nowadays most of these things are available as a point, or otherwise you have available some of these things as a from the satellite sources as a even as a continuous data, as a, you can say, roster, especially the soil moisture and evapotranspiration. So here you can make all those things into the different classes. So based on the, you can say the whether it is a traditional way of collecting data by in situ collection, now it is like a replacing with all the satellite and other systems. And we can have the, you can say, especially now most of things are available like this. This is the one of the important area where a lot of, you can say, changes are occurring. So everything is converted into the either telemetry based, including the sensor systems, not like a more like a physical measurements or manual measurements. So of course, once again the major change is coming in the data is the satellite based observations. So normally either sensor or telemetry or those things are point observations. For some of the studies, especially extreme studies, you may need to have the satellite data where we can have a large area. We need a data set where you can get from the satellite data sets. And here something is not there, right? What you will do, you can do by interpolation. You can interpolate the data set and then you can get wherever it is missing, or other processing methods you can apply and you can get data sets. Okay, so I think some of you are working already. I think you are coming from different backgrounds. I see like at least one point of time when you are studying, whether you are doing your MTech or MSc project, or you are doing your research project. First of all, you start with somewhere the observed data is there, right? I think some of you saw this website. So where the main thing, especially for the extreme studies, you are one of the you can say the best place where you can get almost like a 110 years data set now available actually. And most of the, I think, scholars where I am seeing like whether you go for a climate change studies or hydrological study, hydrologic model, most of the time this become a very valuable input data, especially for even drought studies also. Okay, so you can make a lot of, you are doing in the, you can sometime in the class in the tutorials also, like how to get this data and how to analyze for different indices. So you say something extreme means you need to analyze, right, first of all data. So there are so many indices are there to tell something is like having this extreme characteristics, or some particular climate data is some that data has a lot of changes. So those things to get, we need to have this long term, this observed data. So we can get from IMD. So these are all websites anyway. You can get in the afternoon. You can explore all the things. That is all our planned exercise for you. And you can have the, like there is a lot of, you can say other sources are there. We can get this. So this data set, like we have other sources, not only IMD, we can get from these other sources. Yeah, there is just like a some loose connection actually. Just photo you can check actually. Right now we need to have the climate model, right, model data. So we have the different sources are available. So we can get from this, there is a, I think most of you are, who are working with the climate studies, you can come to know this data sets. This is like one is like a SMIP 6 data set actually. So this data set will contain the, like they will run for whole world. So in that we have the different, we can say the, this is called codex scenarios for the different regions. So we have our Indian region, our Indian subcontinent, we have the, we can say one codex series. So that particular this series we can use when we are studying with our Indian related data set. So we have this from website, we can check for the, that is also I kept here. So we can have, this is called regional climate data for our Indian node point. So we have the, these are all, this is South Asia is there at, this, in that we can get our own data set actually. So for India, we can see this data source. Just like once I show you, so that we are checking those things, we can get those data sets. You know, in the afternoon, we can check some of those data sets, how you are getting. So from the world data, climate data will get, right. From that, they will run the regional climate models and they will keep it ready for the Indian subcontinent. So from there, you can take as starting data and we can use for the any of these climate change studies or extreme studies. So these are the node points for the regional climate data sets. So then you have the so I said, right, we are available the data with the, you can say our climate observed data set, and we have the climate model data set, right? So then that will take care about the, we are giving all inputs related to climate. But most of the times we require the, what is, we are working with any of the extremes, right? Either a flood or a drought, we need to have the spatial data set. So from where to get the spatial data set? So now we have the very, very good source actually, that is like a Bunidhi. So I think all of you can create your login password, like afternoon we will show some of the things. You can try those things. So either you require satellite data set, land use land cover map, soil map, and lot of resources are available. You can download and you can use. This is one of the very good important, we can say, resource where you can get the spatial data set. Okay, so if you want, for example, you want to classify yourself the land use land cover, you want to prepare, you can download satellite data, or you want to use means you can download and you can use, and even digital elevation model also. So one of the best digital elevation model, it is like a 10 meter by 10 meter. So normally it is available for the public. You can ask. It is a Catodem. So that also you can get from this particular source. So most of those are open source, means we can download. Still anybody want, they for research or anything they want, they can even ask for NRSC. They can price also you can get if that is the really you require for high resolution data. Otherwise everything is open source now. From this web source you can get. We will see in the afternoon how you can explore, how you can download data from this particular source. So then this is what I am telling. These are the three sets actually. So best one is like for our Indian scenarios, Indian cases, you can go for the Gatodam now. So it is available. You can check and then you can use most of the, you can say, modeling studies, especially the flood modeling. You want to go for a localized area, you want to for a city, those things, you can go for a Gatodam high resolution. Normal other studies, you can go with the SRTM or Astrodam. So this is the just like a sources for the SRTM dam, and then you can see the land use land. This is what I am saying. So this platform, like whatever I showed, like you see the various you can say data sets which are available. So either a thematic product means all the, you can say, the directly you download and we can use in the model. So satellite data means you need to do something like a processing, classification, and then you can use that depending upon the problem you are attempting, you can use. So here you can get the soil data, one of the crucial, especially I think most of you are now doing. So especially for the drought studies or especially for hydrologic modeling, not hydraulic modeling, soil data is very crucial actually. So where if you are not providing proper data means you will not get the indices or those things not, you will not get properly. So you can't analyze those things. So for that normally now we have the old data set where especially you can rely on the, I can say this FAO data set. Most of the people, especially SWAT model, other models we will use, even HMS models also. This is the database. So some high resolution data sets also now available actually, so that you can check for some of the sources. But most of the times, most of the studies where we are attempting, we are going with these data sets. Okay. And soil moisture, especially the initial soil moisture when the case of hydraulic models, and soil moisture, some of the drought indices. So that is one of the important input. Normally point observations you will make and limited instrumentation, and that is very difficult to interpolate and use. But now things are changed actually. So most of the times we have a lot of, we can say, the data set through satellites. Okay. So you can get a very good reliable source now available. We can download and then we can do. I think some of most of the people who are working on the drought studies, they are I think well aware of these data sets from downloading and then doing some processing and using that one. So soil moisture data getting from sensor satellite systems, downloading and preparing a useful data itself is a one very big research work actually. Most of the some of the even our NIT Warangal students are doing and other places also people are doing. So it is like available in the, you can say, source. So you can check some of these data sets. Okay, so this is like a Nishar mission. I think going to launch this 30th itself actually. This is like going to very important mission, which is like most of you like later really for this extreme studies you are making, right? So that is like one of the very important, you can say, data source. You can get a reliable soil moisture and other type of land use land cover, all those things for high resolution. So the whole mission is the mainly getting the high resolution satellite data, which will take care about the various related, various, you can say, natural or disaster related type of activities to manage those things. So you can see the whole mission actually. This is like a both NRSC and ISRO. Means NRSC means I am saying ISRO and then NASA combined mission it is. So it is like a basically it's a microwave data set. So we are going to get the microwave data set. That is a synthetic aperture radar will be that will get the microwave data which we can use for the different purposes. So it is like a, I said like a, it is going to launch within few days. I think you can see before you are going here, just like you can see what is the way they are doing all things. You can follow up those things. And this is like I said, like it's very important thing. You can see just like that website and how really that is important. Okay. So you can get in that website. They give complete like what exactly they are going and how the both NASA and NRSC, how Miss ISRO they are sharing the data set, all the things. Okay. So now is the data set I said most of the studies we require the stream flow, right? Previously what we have to do is we are going to ask each that gauge stations will be there at different places. We are asking the data set. Sometimes they will give the hard copies. Sometimes they will give few data sets. Now things are most times they are made very systematic process actually. So I think some of you are also doing part of your research or you are working. You may know that one. So one of the a Central Water Commission, they are collecting. They are the responsible for collecting all those stream gauges, especially on the rivers or major you can say streams. So these data sets now they made into one very good website where you can get everything along with the stream data set, stream gauge data set, other things also you will get. So that is this one, India varies. I think most of you or any of you checked all this data set already. So it is like a 1 point, for all our studies, especially our extreme studies, is like a 1 point source actually. Most of the data set you will get, rainfall you will get. So observed rainfall for each gauge stations which are available, and all those stream gauges you will get. Okay. So today we are not only downloading, we can do some analysis also. A lot of analysis tools they kept here. Today first exercise we are starting in the afternoon session. You are working on this one only. So you see that how this India varies, you can really useful for you, and then you can start data getting there and doing initial analysis. Okay. So they brought everything is 1 point. I said 1 point source. Okay. Now most of the times a water levels you say, right? That is normally it is you can say telemetry or sensors or manual reading. But sometimes it's very difficult, right, to get the stream points or river points where there is some accessibility is not there. Still you want to do some very good, you can say the inflow is required. We want to know for some analysis or modeling. So now slowly that is also become, you can say, possible through the satellite observations. Okay. So there is a separate, satellite systems are there. That's satellite systems will look after this altimetry. So this altimetry means is only to measure the water levels, especially the sea surface. That they are looking at a lot of things related to sea or sea level variation, those things. But more to the land also, wherever the water bodies in the land, those things also we can use measure with this what you can call this altimetry techniques, and then source data they are providing, and they are also providing complete a process how to analyze the data and to get exactly the water levels, so that directly you can use in the models. So a lot of you can say work is happening in this area also. So especially the some you can say eastern you see the north states where the rivers are there, and Brahmaputra river, Ganges river, it's very difficult to get some point data. It's very difficult. One is it's a classified data. Sometimes you can't get from India varies, they will not provide. So you will not get a conventional methods. So you can resort to some of these things. So you can get at least some of the data sets on a continuous basis, so that it can be used for the calibration, or we can say the validation. Okay. So this is also a very you can say good. I think a lot of work is. I think Sridhar is along with some of our NIDW scholars, they working on some of the very good you can say aspects related to this GRACE data set. It is so from the satellite system you can able to observe the what is the you can say the overall water content. Water content means it's not only surface, it's subsurface also. So you can able to do this one. This is a very much useful for the basin scale or continent scale, country scale wise. You can estimate the level of you can say water resources available. That is really give you a lot of you can say what you can call as a larger you can say scale, like a state level, basin level type of analysis, especially groundwater related analysis and connected to you can say droughts. All things we can study with these data sets. Okay, a lot of papers are available with Sridhar and other you can see our student who is in the NIT Warangal already did the you can say he's completed his PhD, so we can check some of those papers. It's a very much useful data set, this GRACE data set. And yes, you are getting a lot of data sources, right, from different places. So means now data sources now it is very easy. I said everything is a one click away, you can download and you can get. But later you need to do that something called actually doing some analysis or initial processing. So whatever is getting, you are getting in one is they are in different formats. They are available in a different all the areas it may available. It's not for only the area you are interested. Okay. So it is available for all the time steps. For example, you require only for 10 years. It may be available for 100 years, 110 years. So sometimes that may not be a thing you require. So this software and programming tools will help you in that way. Whatever the way you can cut the data, you can do some initial analysis. Later we can do the visualization. So many things we can do with these programming tools. Okay, so tomorrow actually you can say the session, like that's what we are planning with some of the programming techniques. So from the initial data we are getting from any of the data sources, maybe IMD, from the to generating some climate indices. That's what we are going to try in the lab time actually. That's what we planned. So you can see some of the very important sources. Few are the program based. This second one, Python based, the thing you are trying here in the lab. Even R programming also, I think some of you may be using. Actually it's very easy and you can easily adapt to that one, and then you can analyze the data sets. Okay, so these are the, I can say something like a visualization. We have a lot of web nowadays are available. So SWAT, I think some of you are doing the, when you're doing your research, so that they have provided database, and then we can even some visualization also we can do limited. And this panoply is like all the especially climate data sets. They are available in the separate format, data format, that is called NetCDF. That NetCDF data you can't see in a conventional way, you can't visualize. Few GIS softwares we can check, and that is also limited. You can see it will take a lot of time to visualize. In a quick check, a lot of data, like for example 100-year data at one go you want to see for a whole, you can see India for example, you can visualize in the panoply. It's a simple Python based thing, you can download and you can use. It's a NASA developed thing, you can check that one. Of course SWAT model, that is like they can have a lot of tools nowadays available for analyzing or visualizing the climate data sets. So Google Earth Engine, this is also we are going to try. It's like now it's also a one point source to see the data, to analyze the data, to visualize the data and download the outputs. So we are going to try here in this thing, so you can see how that really going to work actually. So this is the typical interface we used to do in the lab sometimes, just like I put a screenshot to get a view like how really can be done. Simple, some coding will be there on the one side. Actually there is like a console screen and you see the outputs, that way you can see. It's a very interesting interface. You can, some of you can try the R programming interface. So this is a Python, this is the one of the cloud, the Colab, or otherwise you have Jupyter, other environments are there. Any of those things you can visualize, use the data to analyze, visualize and process also. You will, especially this environment you will try. So that too will not like some Jupyter, we are planned that one. You can see how you can really explore those things. So this is what I am saying, the panoply, the you can say data visualization. So this is the very simple, you can say we can download and we can use. We can enough you can try those things. So this is like a data sets from the, you can say SWAT website. So data is available, some visualization tools are available. It's like a, once again a one store like a thing. So what I want to tell you at this point, lot of now data is not a problem, but it's go for a reliable source and then download and then make use of this programming tools and make it better analysis. That's where you can focus. That's where this especially useful for you. Like what are the all available techniques? We will just give a input for you. Like from there you can start and then you can work. Okay. This is the platform, Google Earth Engine platform I told, right? Just like this also you are going to work. Just few screenshots just I kept like how you can work. So just like we can make a few lines of code. You no need to much worry about this code. This is not code like a hard code like your C, C++, Java, like where you feel like a lot of, it's like a difficulty for you to work. But it's very simple. So like it's like a simple like a add one. You are asking something like a add one data set. First then make the data set visible. Then do the some analysis. Then visualize. Like that you are go on telling to the system. There are everything is like available now. So code now it's not a so difficult thing to get. Like for example, you got doubt, simply you ask like NDVI, for example, Google Earth Engine script, I want JavaScript, that thing. It is automatically will get from different sources. You can directly from Google you can get for the ChatGPT you can get. But only thing is our source, your particular study area, you need to modify and you need to work actually. That's the only thing. Okay, that is a very lot of you can see insights you can get and you can see in the course we can. So this is like a simple like a region of interest. That's one we are just we can this thing. So you can satellite data you can see, and you can get the NDVI you can generate. Means what I am saying is within no you can see everything is at like there is no separate thing available for you to have all the. This is very difficult right for you nowadays to have the system and then data at different place, handling problems, all things. We can with this everything we can solve. Especially our studies like a climate extreme studies, right? Normal extending to the at least for the one river basin to the you can say state or the global scale, right? Is very much useful actually. Okay, so all the indices like that for that matter anything we can do. So the main thing I will show you here, important thing, okay, your data is available, you can download or that thing, but you have to see this important aspect is called spatial and temporal scale. What is spatial and temporal scale? When you are selecting data, when you are analyzing data, or you are when you are doing your problem, whatever the problem you are attempting, we need to take care about this important aspect. So spatial scale will tell about the, like depend upon the type of extremes under study, accordingly we need to choose this spatial and temporal scale. So that is like a size of the study area and time step and duration of the simulation. So these things are very important actually. For example, you tell me, you can just tell like a flash floods are occurring. So normally what is the, you can say the, you are one area like I assume like even Warangal only, so the flash floods event are occurring. So what type of spatial scale is important? So you can go for a very, you can say high resolution data or very like a low resolution. Can you tell? Definitely go for high resolution data set. That too is a flash flood data, right? So you have to have the high temporal resolution also. Maybe you may need to get the hourly data set or less than hour you have to get. Then only we can analyze. So that's what is the, what I mean by the, you can say the. So this all like you need to plan. Yes, what is the problem you are attempting, whether you have flood problem or the dot problem, or it is a global scale or it is a regional scale. So what type of, how the event is going to occur, that all things are very important. That's what I am saying, this particular spatial and temporal scale issues. Similarly, the available sources for you. I said right. So from the Google Earth Engine, which is everything you do on the online, to your own QGIS model, which you are going to do, which is everything is offline. You can choose what are the resources available. Accordingly, also other things will change. So you can't make a one very, you can say high computational intensive study simply in QGIS. That will not help you. So you have to set us a different problem. And Google Earth Engine also, like if you are going for a high intensive data set, it will not take you to the, means it will not give immediately. So it will take a lot of time. Since it is a cloud environment, right? So you need to have a separate licensing and you have to have a separate cloud path so that we can do the simulation there. So you can take some computational nodes. That also nowadays it is available from, I think you heard some organization called CDAC in India. So they will give you a computational resources for you. So you can choose the problem, identify the problem, formulate and give all those, you can say time, everything you tell like how much simulation resource you want, they will provide. Model, everything you can select and then you can keep there. So it will run actually. So of course availability of the data set. So downscaling and upscaling capabilities you have to see when you are selecting this, you can say the spatial temporal scale. So these are the simple example we are just show you the how the temporal resolution is important. For example, you are using some land use land cover, just one case just I am presenting here. So Warangal, this is like a different time scale you can see here. So this data set actually the thing different times. You see the what is the changes you are seeing in this particular data set. So the land use land cover 2015 you see and 1995 you see. So same thing if you use means for some flash flood or some analysis, definitely you are not going to get a correct result, right? Since land use land cover is going to be the very important input for most of the extreme studies. So that's what I am saying. So time, temporal scale, like what is the time you are using it, all the things are very important. Okay, and you are going for a temporal scale, right? For example, different data sets. So all these things you have to give input. So like a SWAT model when you are using also, we can give old data. For example, 95 data you are simulating runoff, you have to use that particular data set. 2015 means you have to use this data set. That is possible now. Like a SWAT modeling or other modeling aspect, that is possible. You can give a relevant data set for the study. Okay. So these are the, you can say grid points. You see that grid points and then this is like you see for whole Warangal district actually it is very big area, only covering 7 to 8 points, climate grid points. So you see the lot of gaps are there, right? So with that points it is very difficult for you to analyze. On the right side you can see there is like a little bit high resolution or RCM grid points. This is the grid points where you can't, you can say more, you can say spatial information. So what I want to tell you, like there is a coarse grids. Now it is like a 0.25 is available. That's what we are going to do in the IMD. So 0.1 degree. Still further also you can check accordingly. You can choose for your studies for the data sets. Otherwise, for example, very small area you are studying here and points are very far away. You may not get a correct connection to the climate. Okay. So this is the, you can say of course, this you see the how much dense this network you are using. That is also like a study. So whether you are studying hydrologic study, hydraulic study. It's also very important actually. So dense network you want to use, this will generate your any ArcGIS or QGIS softwares, they will generate this thing. So you decide like a, since if you are using very high intensive, actually the simulation you need a more dense network is required. Simple hydrology study, you may not require a lot of, we can say drainage network is not required. Okay. So that's what is the thing, of course, like a, before you are selecting data, you see the existing literature. Some most of the times what is the thing we will ask from the scholars or some students. So I am using some drought study, what type of climate data I have to use. Some extreme flood event I am studying, what is the data set I have to use. So future prediction I have to use what data. So very simple thing, logic, first you get to the literature. So similar studies, what type of data they are using, that will give you guidance. And see the other, you can say sources like a, what is the, that will give you a lot of ideas. For example, we are almost like a 10 to 20 use cases, like I said, like SAR is also a part of a Spark project, I said, like we are mentioning morning. So we made a lot of use cases for the different basins. So you can see like whatever data we are using, and then that will give you an idea, like when you are studying also you can take up those things. Okay, so of course, what is the data set, like a background, what you have to see, this very important when you are selecting your data set, you can check. So of course, so sometimes you say that very high, you can say scale data is there, but you are using a drought for entire Telangana you are studying. It is like a high, you can say scale, like for example, 0.1 by 0.1 is there. That may not help you. There is no point in getting that much high resolution data set. So you can go for the other way around. So go for a 0.25, no problem. That you can study. That is all like depending upon the study, like what type of study you are doing. That is an important thing. So this is like a way you need to give the referencing data. Since like you are studying, right, later somebody will study, that it will all continue, right. Always is a better way of whatever data you are using your study, you need to mention a proper way. Like I said, like a resolution, data source, and type, all things we need to mention a systematic way. This is the final thing, actually the thing. So nowadays actually the lot of data sets are available. It's very easy for you, like unlike when we are working in the almost 20 or 30 years back, it's very difficult to get data. Now data you will get, but we need to check whether how much reliable it is and how much worth we can use, so that your results are very easily acceptable by the community. That's more important actually. So most of the times actually you are spending a lot of time on the, you can say the, we can a lot of times you have to spend that some time, good time for the, you can say the validating the data set, calibration, validation, those things you need to make. And we need to get some inferences, right? That initially you have to spend so good amount of time for checking so many sources inside that one. Take the data which is already used by public, some people, check for your area, see whether it is useful or not, then make some initial analysis, it is there, and then do the some validation of things. Then you can start working. Otherwise you are revolving around data only, means you will may miss the important time. Later you won't get much time for analysis. So people want to say they will start in between the research. They say that some new data came, once again they will start from this thing. By that time you will miss the important time. You are in the middle, means you proceed first. Later you can compare. That's what is the thing you can do. Okay. So always like sometimes data is very good. Your analysis is not good. Like for example, some statistical techniques you are using. All those things, there is a possibility. Nowadays you are using programming tools, I mentioned, right? Nowadays programming, every code is available from different sources. That is their way of understanding, their way of coding is different. But the way it is required for equation or whatever the thing it is required for, you may be different. So you need to check. Directly code downloading and using means you will miss important things. So always see the basic formula, what they are using, what is the code, whether you are getting correct or not. Accordingly you can apply. Otherwise you may miss in the analysis. Data is problem, that's different. The analysis problem is nobody will help you, like nobody will accept your results. Or it will become a letter skewed data and then results, and then nobody will say you are doing a good analysis actually. So it is always better to check the data before using, that's the main thing. So that's all, like a lot of things which are only database intensive research we carried out, and then I said like Cesar and myself we worked in different things. It's all available in public domain. You can see like how it's only verifying the data and understanding data. That itself is we made some studies, you can check some of interested things. So now it is like yes, it is open for you, like you can have any questions. So like one important thing is like can we get the crowdsourcing data on social media also as one of the input data? It's possible for some of the studies. Yes or no? So now it is lot of work is happening that area also, along with your conventional data sets. You can use some of those things that is useful for especially for the extreme studies like floods, other places. People are using slowly. So we will see one case study when we are done here in our campus, means our institute. I will present in the last before or last day. So then I think we have the best for stream gauges. What is the Indian data set for CWC, and then India varies we can get spatial data. So like a NRSC or that data is that's sufficient for you. No need to see for anybody for Indian thing. You can get all your resources. Okay. So that's all from my side actually. Any questions? Now it is open for the discussion. 1 or 2 minutes then before I hand over to Professor Sridhar. Any questions? I think most of you are working in the different data sets. I think we are for your projects. Temperature data, what you are saying, like whether the observed data set, observed data is IMDT there actually, but only thing is the data, it is not a 0.5 meter I think, or 1 degree or 0.5 degree. So, but other thing is 0.25 degree or even 0.1 degree also available for rainfall. But temperature is we are not having that much high resolution data set. Okay. On for future things same, like a Cortex data, right? They will give the parameters. One is like a maximum temperature, minimum temperature, rainfall, and other parameters are there. Normally, most of the studies, especially drought or our hydrologic studies, normally these 3 parameters sufficient: maximum, minimum temperature, and rainfall. That okay? So with this, I think I said like everything is. We are keeping all these things in the, once again, that by afternoon I will share this portal to all of you, that our drive, so that all my presentations as a PDF and see the presentations also available for you, and even tutorial, everything is available. Already tutorial is copied to you, all of you, you can see, and all things are use case models we tried here, code and everything is kept for you, so you can go on. Anyway, we'll explain all things in the next course. Okay. So with this I will next hand over to Sridhar. If you want to take, we'll give